Here one quick biochemistry basics here. Let's talk about gas chromatography. Gas chromatography is a chromatography technique used for the separation of volatile compounds. Volatile compounds are the compounds that gets easily vaporized at room temperature. Let's see the components of gas chromatography. The column. The column used in gas chromatography is very long and arranged in a coil. The column used in gas chromatography are of two types. Number 1, packed column, and number 2, capillary column. Packed column. Packed column can be made up of glass or stainless steel. The length of this column can vary from 1 to 3 meters and has an internal diameter of 2 to 4 millimeter. The capillary column. The capillary column is made up of fused quartz. These columns are very long and have length from 10 to 100 meters and have an internal diameter of 0.1 to 1 millimeter. The column is placed in a chamber so that a uniform temperature can be maintained. The stationary phase. The stationary phase is packed in the inner wall of the column. The stationary phase is made up of silicon grease or wax which can withstand a high temperature. The mobile phase. The mobile phase use is usually an inert gas like helium or unreactive gas such as nitrogen. The mobile phase gas is kept in a cylinder which is connected with the column via molecular sieve. The molecular sieve separates the unwanted hydrocarbons, oxygen and water vapor that may interfere with the test sample during analysis. At the end of the column, there is a detector which detects the sample. Let's see the working of gas chromatography. The sample which is to be separated is mixed with an appropriate volatile solvent such as heptane, acetone or methanol. Just before the column, there is a septum that allows injection of the sample. The temperature of the injection region is kept 20 to 50 degrees Celsius high as compared to the column. This allows rapid volatilization of the sample. Once the sample is volatilized, it passes down the column where the separation occurs. During analysis, the temperature of the column is kept between 150 to 300 degrees Celsius. Separation occurs based on the interaction of molecules between the mobile phase and the stationary phase. The less volatile molecules interact more with the stationary phase and move slowly, while the more volatile molecules interact more with the mobile phase and moves fast down the column. Once the separation is completed, the detection is done with a detector attached at the end of the column. One of the most common detectors used with gas chromatography is flame ionization detector or FID. The flame ionization detector has 3 inlets, one for the carrier gas which comes from the column and the other 2 for hydrogen and oxygen. The igniter ignites hydrogen and oxygen to produce a flame. When the sample molecules reaches the flame, they get ionized and the electrons are released. Across the flame there are 2 electrodes, each with a positive and a negative charge. The electrodes detect the electrons generated by the ionization of the sample. The electrons are detected in the form of current which is amplified and detected by the computer. When the sample is detected, the computer gives a peak with respect to the retention time of the sample. The area under the peak gives information about the concentration of the sample. If the concentration is less, the area under the peak will be less, and if the concentration is more, the area under the peak will be more. Now, for the detection of unknown samples, we need to have standards. Let's understand this with an example. Suppose we run methanol as our sample and the peak of methanol is obtained at 5 minutes. Next, we run acetone as our sample and the peak of acetone is obtained at 3 minutes. Next, we run unknown sample and we get this chromatogram. Now, using information from the standards, we can say methanol is present in the unknown sample, whereas acetone is absent. The remaining peak is still unknown as we do not have any standards to compare its retention time.